Okay. All right. Yesterday we started talking about exponential functions. An exponential function, your variable is the exponent. And so we graphed two exponential functions. One was an exponential growth function that's increasing continually, and then an exponential decay function that's decreasing continually. Okay? And what you notice is as it's growing, if you go way out here on to this end, it's growing very, very slowly because it's close to zero. Then it gets right in here, it starts growing rapidly. It speeds up. And then when it gets way up here, it's really growing rapidly. Okay? So it's not consistent growth. It speeds up. And then the exponential decay, it's decreasing rapidly and then slows down. Okay? All right. And then we talked about all these numbers and what they mean, and that's what we're getting ready to do. Use the graph of f of x equals 2 to the x power to describe the transformation that results in each function and sketch the graphs of the functions. So we had gotten the 2 to the x graphed on each one of them. So this is f of x equals 2 to the x. F of x equals 2 to the x. And f of x equals 2 to the x. Okay. All right, now we're going to graph 2a is g of x equals 2 to the x plus 1. So how is this one different than the basic one, the 2 to the x?
It has a plus 1.
It has a plus 1 as part of the exponent. So that's going to be this h right here. So it's going to, that means it's going to move left or right. This is going to make it move left or right 1 unit. And it's opposite what you think. So which way is it going to move, left or right?
Right.
It's going to be left because it's opposite what you would think. So it's going to translate left 1 unit. Now, that's the only transformation that we see here, okay? So what we want to do is take these points that we plotted and just move them all to the left 1 unit, okay? So 0, 1, we're going to move it over here. Then we had 2, 1, that's going to move over here and now be the y-intercept. And then we had 2, 4. It moves over here to 1, 4. And then 3, 8 is now going to be 2, 8. And then, of course, it's still going to be getting closer and closer to 0. So there is f of x equals 2 to the x plus 1. Excuse me. Okay. So you can see that it moved left 1 unit. Now let's talk about all the things when we analyzed yesterday and looked at the characteristics. Of course, this is an exponential growth. It's still an exponential growth. So all of these things that we know about an exponential growth function, did any of them change when we transformed it? There was one thing that changed. The y-intercept changed because this one moved over here. So now our y-intercept is 0, 2. Well, actually, yeah, it looks like it moved up 1, but it was really this point that moved left 1.
Yeah, but the intercept moved up 1.
No, the intercept moved left 1. There's the old intercept right here.
New intercept is up 1.
I know what you're saying, but it did move up 1, but it's really not the same point that moved. You understand what I'm saying? So the y-intercept is now 0, 2. Everything else stayed the same. Okay? All right. Let's look at 2b. H of x equals 2 to the negative x power. So how many transformations do you see here of 2 to the x?
1.
1. And what is it?
A negative x.
The negative in front of the x. So if you have a negative up in the,
It's a reflection.
it's going to reflect over the y-axis. So we're just going to reflect all the points over the y-axis. So this little point right down here that was negative 2.25 is now going to be over here at 2.25. Okay, then this one's going to move right here, reflecting over the y. Now look what happens to the y-intercept. Since it's on the y-axis, it's going to stay put, isn't it? Then this one will reflect. Oh, this up here, I put f of x. It should be g of x. And this is h of x equals 2 to the negative x. So, how did this one change? Is it exponential growth anymore? It's decreasing, so it's exponential decay now. All right, so let's write down everything that changed from the original. Here's the original. So it used to look like this, now it looks like this. So let's talk about everything that changed. Did the domain change? All right, what about the range? All right, what about, well, let's just go back over here just a minute. What about the y-intercept? All right, there's still no x-intercepts. What about the asymptote? No. What about end behavior? Yes, the end behavior flip-flopped. So our end behavior on this one is the limit of h of x as x approaches negative infinity. So as we're going from right to left, what's the y value doing?
Cross.
What's it approaching? Infinity. And then the limit of h of x as x approaches positive infinity. So as we're moving to the right and x is getting larger, what's the y value approaching? 0. So those two flip-flopped. On the original, you're approaching 0 as you approach negative infinity, and infinity as you approach positive infinity. This one's right the opposite. And then what about increasing, decreasing?
Yeah.
That definitely changed, right? This one is decreasing from negative infinity to infinity. All right, 2C.
Are we finishing this whole package today?
Probably not.
But we're doing IXL tomorrow.
So we'll be finishing this next week.
Monday.
All right. This one, 2C, is j of x equals negative 3 times 2 to the x. So how many transformations does 2 to the x have now?
2.
2, good. It has this one, the negative. What does the negative out front mean?
Reflect over x-axis.
Good, so it's going to reflect
That's why
over
we have a bigger graph.
the x-axis. All right, and then what does the 3 mean?
It's vertical stretch. But
It'll be a compression.
more than
It's bigger than 1, so it's a stretch. Vertical stretch by a factor of 3. Now what that means is that the y value, the old y value for each x value is going to be multiplied by 3. And we're going to flip it. Okay? So we're going to flip over the x-axis. So here's our mirror right here. All right, but we've got to multiply by 3. We got to take the y value and multiply by 3. All right, so here, if we flip this over the x-axis, it would be here at 0.5. I mean negative 0.5, right? But what's negative 0.5 times
You
3?
forgot 0.25.
1.5.
Well, that one will take care of itself here in a minute. It's not going to be that much difference. What? 1.5. So what was 0.5 is now going to be negative 1.5. So it's going to be here now. All right, the y-intercept. If you reflect it over the x, it would be here
1, so it'd be 3.
at negative 1. So you multiply that times 3, that would be negative 3. All right, then over here at 1, our y value was 2. So if you reflect it over the x, that would be at negative 2, but we got to multiply it by 3, so that would be
6.
6.
So that's all you can.
2, 3, 4, 5, 6.
That's all you can fit.
Yeah, because 3 was what, 4?
And that'd be 12.
No, 2, I'm sorry, I was looking, it's 2, 4, which would be
12.
12. And that's not on there. So yeah, that's the only ones we can do. Now the reason I didn't do the 0.25 is, well, I guess we could have. If this is 0.25, you reflect it here, and 0.25 times 3 is 0.75, so it would be negative 0.75 right
Pretty
here.
sure it needs to be
Whoops,
1.
wrong one. Sorry. Ignore that one. So you can see that this one is much steeper going this way. It's decreasing a lot faster than this one is increasing here. Okay? All right. Now let's talk about what's different. What changed when we did the transformation? Did the domain change?
No.
No. What about the range?
Yes.
Yes.
It went from 0. It went from infinity, negative infinity.
No, it went from
0
to infinity
No, you said you
to,
go to the lowest.
yeah, I know. So this one is from
It's negative infinity.
to,
0.
yeah. I was talking about the original. The original one started at 0 and went to infinity. This one, since it flipped over the x-axis, starts at negative infinity and goes to 0, not including 0. Okay, what about x-intercept? There's still none. Well, we don't even need to write it. We're only going to write the ones that changed. Y-intercept. It changed, didn't it? What is it on this one? 0, negative 3. Which, if you think about it, if it was 1, you multiply that by negative 3. There you go. All right. Asymptote. Did the asymptote change?
No.
No. It's still the x-axis, y equals 0. In behavior.
That changed.
Okay. Well, actually going to the left didn't change, did it? It's still approaching 0. But going to the right, as it gets bigger and bigger, it's getting, y is going down. It's going towards negative infinity, not positive. So part of our end behavior changed. Just the limit of j of x as x approaches positive infinity. It's approaching negative infinity. It's going down instead of up.
So we get out at 1 o'clock.
Yes.
So 15 minutes.
All right, what about the increasing, decreasing?
It's decreasing.
Yes, that's different. It's increasing here, and now it's decreasing. Okay. Now we're going to kind of switch gears a little bit. Now we're going to talk about what's called the natural base E. Natural base E, Wesley.
Natural base E.
Mm-hmm.
What is that?
I'm fixing to talk about it, but I want to get your attention before I start talking about it. Now, the book goes in pretty deep about how the natural base E came about. I'm not going to go into all that right now. We just want to kind of know what it is and use it. Actually, the most commonly used base in real-world applications of the exponential function is not 2 or 3 or 1/2. It's E. Okay? So it's the most commonly used base in the real world. In fact, it's so commonly used, there's a button on your calculator for E. Now, just to give you a little bit of background, E is based on this little formula right here, this limit, okay? And you can kind of see it at work right here. So if X is 1, then it would be approaching 2, and so on. Look, when you get to X is 1,000,000, then you get close to this number E. Now, E is, all right, think about pi. E is like pi. Okay, pi is what?
3.14.
3.1415. It actually never ends, but we usually just round it to 3.14. Okay? E is the same way. It is an irrational number that never ends. It's 2.718281828, and this mathematician named Euler, actually took it out 23 places at some point, okay? But we don't need to worry about that. So this is what we're going to be using. And your calculator has an E button. So it's sometimes called Euler's number. So if you ever hear in any class, in college or wherever, they start talking about Euler's number, they're talking about base E. And that's from that Swiss mathematician. Now, here is the graph of base E. Now, it is very similar to, see, f of x equals 2 to the x. It's very similar to that one. It's a little bit wider because instead of 2 to the x, this would be 2.72-ish to the x. Okay? So you can see your y-intercept is still 0, 1. Because if you raise e to a 0 power, it's still 1. Anything raised to 0 power is 1. But if you raise e to the first power, it would be this number right here. Then if you raise e to the second power, it would be 2.718281828, whatever. It would be about 7.3, I think is what we figured out this morning. Okay. All right. So we're going to be working with this natural base E. So before we actually do some real world problems, some financial type problems, we are going to do some graphing with it just so we can get used to it. And this talks about how you read it. You read it like e to the 4x. That's how you read it. E to the 4x. Okay? No. All right. Use the graph of f of x equals e to the x to describe the transformation that results in the graph of each function. Then sketch the graphs of the functions. Okay? All right. Well, we're just going to copy this one first. We're going to graph it first. So, 0, 1, and then 1, 2.7-ish. And then 2 would be 7.3-ish, I think, is what we figured out this morning. Now, let me show you on the calculator. Okay, if you go to your graph, All right, look right down here to the left of the 1 button, all the way over to the left. See that e to the x? There's your base e.
I've never seen that button.
Okay, so
I just
e
got there.
to the x power. Enter. There it is. All right, now let's look at the table. Control T. All right, it's 0, it's 1, 1 is 2 point. There's that e number right there, 2.71828. And then, yeah, 7.4.
It should have been 7.4.
It's close enough because
Very
if our graph was this big, it might make a difference. But as close together as that graph is, it's not going to make a difference. And then look what happens at 3. It jumps up to 20. And you're going to see, look what keeps happening. Look how fast the y values jump. See, they're getting big fast. The higher you go.
The next one's going to be like 3,010.
You're close, 2980. Then, if you go backwards, go the other way, on the other side of 0.
They drop real fast, too.
Well, but wait, look what starts happening here. And that right there is a scientific. But look, it's getting closer and closer to 0, so it's dropping really, really. When it gets like right here and it starts getting almost horizontal, it's changing very slowly. Okay. Okay, so let's go back. All right. Let's go ahead and graph it on the second one too. We're going to be working with it on both of these graphs. So 0, 1, 1, 2.7-ish, 2, 7.4-ish. Does that make you happy?
7 point. Yep. A big difference.
Oh,
Compared to the last one.
okay. All right, so now let's do some transformations. Example 3a. We want to do a of x equals e to the 4x power. So, how is that different from e to the x?
It slides over right forward.
Actually, it's horizontal compression. It's opposite. Well, yeah, it's opposite the vertical. So this one is compressed horizontally by a factor of 4. Just put horizontal compression. It's good enough. Now, what we're going to do to get some points is we're just going to plug in a few numbers here. We'll plug in 0. So if we plug in 0 for x, what's 4 times 0? So that would be e to the 4 times 0 power, which would be e to the 0, which would be what? 0 what? E to the 0 power is what?
0 e.
1. Anything to the 0 power is 1. Don't forget that. A million to the 0 power is 1. So the y-intercept doesn't change. All right, now let's say e is 1. So we'd have e to the 4 times 1 power, which would be e to the 4th. Well, put your little, you got your calculator there, put e to the 4th. It's going to be like 2.7 to the 4th power. $54-ish, right? 54.6. Okay. So that one,
Okay, we
when you
have one.
listen, when you horizontally compress it, it's going to go like this, which is going to make it narrower, so it's going to shoot up higher faster. Okay? So basically, you're right. what you got to understand is that if we're going to sketch this, at 1, we're going to have to be at 54. So that means this thing is getting steep fast. It's going through 0, 1, and then shooting up like that.
So we're going through 0, 1, shooting up.
So it looks almost vertical because it's going up so fast. What would the next one be just for fun? What would 2 be? That would be e to the 8th. Put e to the 8th and tell us what it is. 2,900 and something? Yeah, so when you get to 2, you'd have to go all the way up. So yeah, it's getting steep fast. Okay. All right. Now let's look at example 3b. And we got hopefully just enough time. E to the negative x plus 3. Now we can do this one without a table. How many transformations do you see here?
2.
2. What does this one mean?
Yeah.
Reflection over y.
Reflect over y, and what does this one mean? The plus 3. So it's going to go up 3.
Mm-hmm.
So reflect over y-axis, and I'm just going to put up 3.
Okay, so reflect. Wait. 1, 2, 3. This one.
So this one's not just going to go straight up 3, right? Because if reflected, it's in the same spot. So it's just going to go 1, 2. It's going to go to right here. All right, this one we're going to reflect over to here and go up 3. 1, 2, 3. This one we're going to reflect over here and go up 3. 1, 2. Actually, it's going to go off the graph just a little. All right, now here's the other interesting thing. Our asymptote is changing on this one. Because there's no stretch or anything. So that means right here when
Dang it.
the y-intercept is 1 above the asymptote, it's still just going to be 1 above the asymptote. The asymptote moves up 3 too. So on this one, this is the first one we've had where our asymptote actually changed to y equals 3. That's kind of sad the way I wrote it, but oh well. I put y equals 3 first and then went back and added asymptote and then leave myself enough room. And we could talk about all the other things, but I think y'all get an idea. Look at the range now. What's the range? What's the lowest? What's the lowest? How low does it go? No, this one. 3. So from 3 to infinity is the range on this one, not including 3. You getting that, Wesley?
Yeah.
Okay. All right. Of course, it's decreasing now instead of increasing. The y-intercept changed. In behavior, flip-flopped. What else? Still no x-intercepts. Domain stayed the same. So, okay, we'll stop right there. It looks like it's not focusing very well.